In this video, we're going to look at how to solve this integration problem together. Here you have integration problem consists of two parts. The first is e to the x, and the second is cosine x. We know how to calculate the integral of them separately, but when they multiply each other, we need to use a technique called integration by parts. The goal for integration by parts is to separate your function into smaller pieces, so you know how to calculate the integration by them piece by piece. The equation we're going to use, let me write it here, which is going to be u dv is equal to uv minus v du. And u and v here are your new variables. In this question, we're gonna set u equal to cosine x. So du, which is the derivative of u, is going to be negative sine x dx. And our dv is going to be e to the x dx. So our v, which is the integral of the right part, is going to be e to the x. So there in general is an order how to pick your u and v, and the way to pick it is called ilate. I-L-A-T-E. If you haven't heard of this, just search online what does ilate means in integration by parts, and it will tell you how to pick your u and v in order. Okay, now we have our u and v. The next step will be plug it into the right side of the equation. Let's rewrite our function in terms of u and v. So first term we have u times v, which is cosine x times e to the x minus integral of v du, which gives us integral of v du e to the x du, which is going to be negative sine x dx. Let's just try to simplify it a little bit. We get cosine x times e to the x plus the integral of e to the x sine of x dx. And you might be thinking, this part of the integral, we still don't know how to calculate. That's right. So now we need to use the integration by parts again. So this part, we can call it repeat application. Which means you need to repeat integration by parts again, and you will see how that will simplify our question. So in this case, let's set u equal to sine x. Then du, which is the derivative of u, is cosine x dx. dv is going to be e to the x dx. And v is going to be e to the x. So it's very similar to the one we had on the top. The only difference is on top we have e to the x times cosine x. Here we have e to the x times sine x. Okay, so let's try to rewrite the new integral. So e to the x sine x dx is equal to uv, which is sine x e to the x minus here v du minus the integral of e to the x du, which is cosine x dx. Okay, so now let's plug in this part of the expression into our original equation and see what we will get. So that gives us, let's just rewrite this part first. Cosine x e to the x plus, so this part, because of this equation, we have the things on the right, which is sine x e to the x minus the integral of e to the x cosine x dx. Okay, so let me erase the right side so we can see it more clear. Here, let's just write it up. Here we get minus the integral of e to the x cosine x dx. So this part here, remember what our original equation is equal to, which is the integral of e to the x cosine x dx. So that's our original equation, that's the thing we want to calculate. Okay, so now we see why this can simplify our calculation. It's because our question is on the right side. And this part, which is also what we want to calculate. Okay, so now you see this part of the function happens also on the left side. So let's combine them together, which we get cosine x e to the x plus sine x e to the x is equal to, so on both sides we plus this term, which gives us 2 times the integral of e to the x cosine x dx. So therefore, we treat this part as our only variable. So we would get cosine x e to the x plus sine x e to the x divided by 2 is going to be the integral of e to the x cosine x dx. And this part is the answer for our question. So this question not only uses integration by parts, but also we have to repeatedly using it twice so that some part can be cancelled out. This method is helpful when you have a question that part of it is exponential function, the other part is a trig function.